Okay, now let X be the number of bad hair days someone reports in a month. And let's assume we have the same mean and standard deviation we have over here, although in this case we're going to be assuming that it's been calculated for a much larger number of people. So let's assume that the mean is 5, the mean number of bad hair days in a month is 5, with a standard deviation of 1.4. And we're going to have 400 people report this number each month for a year. Now, in a year, there are going to be seasonal variations. Some months are going to tend to have more than others. But let's assume we have an ideal situation, tropical island someplace, same weather all year, and no other factors that would make one month tend to have more bad hair days than another. So this thing of bad hair days, it can deviate from person to person with this standard deviation around this mean, but it's going to be the same basic conditions month to month. Now, so we can say that X bar, the mean number of bad hair days, won't always be 5, but it's going to stay close to 5, and your standard deviation is going to stay close to 1.4 month to month through the whole year. Well, then you're going to get 12 values for X bar, one for each month. Each month, all 400 people report their hair. You're going to add up, report their bad hair days. You're going to add all those up, divide by 400 to get a mean. Okay? Those means are going to cluster pretty close to 5. Those means aren't going to go to 2.2 or 7.8. They're going to cluster much closer to 5, and we can figure out how much closer they should cluster to 5. Theoretically, in the ideal case. Okay, so we're going to get 12 values, call those values x1 bar, x2 bar, up through x12 bar. So we got 12 numbers here. Each number represents an average, just like the 5 here. Sometimes it might be 5.1, sometimes it might be 4.8, and so forth. Anyhow, we take those 12 numbers, and we can calculate their mean and standard deviation. And we expect the mean is going to be pretty close to 5. The standard deviation of these averages of the results from the 400 people over each of the 12 months, those are going to have a standard deviation not of 1.4. 1.4 is a standard deviation from person to person. Okay, this is a standard, we're trying to calculate the standard deviation of these means. And to get that, we're going to divide the 1.4, the person-to-person standard deviation, by the square root of how many people there are, by the square root of 400. And that's going to give us about 0.07. Okay, so, okay, that's all I want to say about that at the moment.